In this video, we're going to look at angles represented in radian and degree form. The first thing that we want to do is kind of get a new perspective of how we look at an angle. Up until this point, we've kind of been thinking of as angles as being stationary, but now we're going to look at them as being volatile, where they can move. Every angle has what we call an initial side and a terminal side. And in most cases, the initial side of your angle is going to be the positive side of the x-axis if you're thinking of the coordinate plane. So imagine your coordinate plane being right here, your x and y axis. Your initial side in most cases is going to be the right side of your x-axis. And then the terminal side of your angle is where your angle ends. Now your angle can open in two different directions. If your angle opens up, that's considered a positive angle. If your angle opens down, that's considered a negative angle. You can also think of your positive angles as going counterclockwise and your negative angles as going clockwise. Okay, so up until this point, we've been measuring angles in degrees for the most part. Today we're going to look at radians and how they compare to degrees. 1 radian is the angle measure when the radius and the arc length around the circle are equal. Okay, so to illustrate this, I'm going to draw another coordinate plane. And I'm also going to draw a circle with the center of the circle being at the origin. So your circle looks something like that. If our angle's initial side is starting on the positive side of the x-axis, like we said, so this is the initial side of our angle. If we take that point on the edge of our circle and travel along our circle until we reach a point where the radius coming out to that point and the distance around the circle to that point are equal, then that angle measure is 1 radian. So this is not an exact drawing, but it looks like the distance right here is about the same as the distance right here. So that would make that angle right there 1 radian. So this is your radius. And this is called arc length, and we typically measure arc length with the letter S, and we'll talk about that more later. But when those two are equal, S and R, that makes 1 radian. So you can see that it takes roughly 1, 2, 3, 4, 5, 6, roughly 6 radians to make a circle, whereas it takes 360 degrees to make a circle. Now, the exact number of radians that it takes to make 1 full revolution around the circle is 2 pi. So if you take your calculator and you type in 2 pi, notice that's about 6.3 radians, so really close to 6 radians around the circle. So 2 pi radians is the equivalent to 360 degrees, which means 1 pi radian is the equivalent of 180 degrees. So some things that you want to go ahead and start memorizing now. If you think of this as a circle in your coordinate plane, this place over here represents 0 degrees. It also represents 0 radians anytime your line goes straight out to the right. When your line goes to the top, when your angle opens to the top, that's the same as 90 degrees or 1/2 of pi radians. 1/2 of pi radians is pi halves radians. So 90 degrees and pi halves radians are the same angle measure. If your angle opens all the way up to here, that's 180 degrees. 180 degrees, remember, is the same as pi radians. And then if your angle opens all the way down here, That's 270 degrees, and 270 degrees would be 1 pi and a half radians, so we call that 3 pi halves radians. And then if your angle opens up all the way back around to where it started, that's 360 degrees or 2 pi radians. So you need to go ahead and start memorizing these major angles in degrees and in radians. All right, the next thing we want to look at are coterminal angles. Coterminal angles are angles that have the same initial and terminal sides. There are infinitely many coterminal angles. Okay, let me try to illustrate one example of this. Let's say we had an angle whose initial side was the positive side of the x-axis and whose terminal side was about right here. So we have a positive angle right here. Okay, to get a coterminal angle for that, we still want our angle to start here and we want our angle to end here to be coterminal, but it can't just be this small angle again. So the way we get a coterminal angle is we start at the same place, we go through that angle and make a full revolution and then come back and end at that terminal side again. So basically we've added a full revolution to the angle that we already had. So anytime you want a positive coterminal angle, you're going to add one revolution. And one revolution is either 2 pi for radians or 360 degrees for degrees. Okay, if we want a negative coterminal angle, for a negative coterminal angle, we still want to start here and end here, but we've got to go in the other direction. Remember, negative angles open down, so we would start here and we would come around and end here. To get a negative coterminal angle, you do the opposite. You subtract one revolution. So for a negative coterminal angle, you subtract one revolution. And again, one revolution is either 2 pi if you're dealing with radians, or it's 360 degrees if you're dealing with degrees. So for each of these examples here, let's find both a positive and a negative coterminal angle. Notice all of these are in radians. If we don't see a degree symbol, we automatically assume that we're in radians. All right, so for 13 pi sixths, let's find my positive coterminal angle first. So I'm going to take 13 pi sixths and I'm going to add to that 2 pi. All right, when you type this in the calculator, since both things that you're adding have pi's in them, you do not type the pi. You're going to type 13 divided by 6 plus 2. You're going to get that decimal, then you're going to change that to a fraction. And to do that, you're going to hit math, fraction, and enter, and you get 25 sixths. So our answer is 25 pi sixths. Now the abbreviation for radians is RAD, but you're not required to write it. If you don't write the RAD, it's automatically assumed to be in radians anyway, unless there's a degree symbol. So I'm not going to require you to write RAD. Okay, just make sure that you don't write the degree symbol unless you're specifically dealing with degrees. All right, to get a negative coterminal angle, we are going to take the 13 pi sixths and we're going to subtract 2 pi. So 13 sixths minus 2. Remember, don't type in your pi's as long as they both have 1. It's kind of like combining like terms. If those were both x's, you wouldn't worry about the x's. You would add or subtract the coefficients in front. Okay, so there's our decimal. We're going to change that to a fraction and we get 1 sixth. Okay, so I have a problem here. 1 sixth is the same as 1 pi sixth or pi sixth. That's still a positive angle. We wanted a negative coterminal angle. Okay, so if I've already subtracted 2 pi and my angle is not negative yet, I subtract 2 pi again. So now I'm going to subtract 2 pi. Remember that pi 6, that's really 1/6 pi. So in my calculator, I'm typing 1/6 minus 2. I get my fraction, or my decimal, sorry, change it back to a fraction. I get negative 11 pi 6 radians. So this is what I mean by there are infinitely many coterminal angles. I could keep on adding 2 pi or keep on subtracting 2 pi and get multiple answers that are correct. Okay, for 3 pi fourths, let's find our positive one first. So let's do 3 pi fourths plus 2 pi. So remember, you're typing 3/4 plus 2. Change that to a fraction, you get 11/4. So 11 pi fourths is your positive coterminal angle. Now we're going to subtract 2 pi. 3/4 minus 2. Change it to a fraction, you get negative 5/4, so negative 5 pi fourths. Okay, negative 2 pi thirds. Negative 2 pi thirds plus 2 pi for my positive, so I'm going to type in negative 2/3 plus 2. And I get 4/3. So 4 pi thirds for my positive coterminal angle. And then for the negative, we take negative 2 pi thirds and we're going to subtract 2 pi. Get negative 8/3, so negative 8 pi thirds. All right, and the last one, negative pi fourths. Remember, that's the same as negative 1/4 pi. You can think of it like that. And we're going to add 2 pi. So negative 1 divided by 4 plus 2 gives us 7/4. So 7 pi fourths. And for the negative coterminal, we're going to subtract 2 pi. Negative 9/4, so negative 9 pi fourths. So that's how you're going to find your coterminal angles. Just remember that if these were in degrees, instead of using 2 pi, I would just be using 360 for degrees. All right, the next thing that we want to look at is how to find complementary and supplementary angles. And this is something that should be familiar to you from your geometry or your math 2 classes. Complementary angles are two angles that sum to 90 degrees. But because we're focusing on radians a little more heavily now, 90 degrees, remember, is the same as pi halves in radians. Supplementary angles are two angles that sum to 180 degrees. And 180 degrees, remember, is pi radians. So what we're going to do is, if we want a complementary angle, we're going to do pi halves minus the angle we're given. If we want a supplementary angle, we're going to do pi minus the angle we're given. One thing to remember is complementary and supplementary angles can never be negative. If we subtract and we get a negative answer, we're just going to say no complement or no supplement. That means the angle was already larger than 90 or larger than 180 to begin with. Okay, so for the first one, we have 2 pi fifths. So let's find its complement first. For its complement, we want it to sum to pi halves. So we're going to do pi halves, or 90, minus 2 pi fifths. Okay, remember when you type it in your calculator, that pi halves is really a 1/2 pi. So you're going to type 1/2 minus 2 fifths. And you're going to get your fraction, which is 1/10. Then put your pi back in there. 1/10 is really pi tenths. Okay, for the supplement, pi for 180 minus 2 pi fifths. All right, when you type this in, remember pi is really 1 pi. So it's going to be 1 minus 2 fifths. changed to a fraction, we get 3/5. So 3 pi-fifths is the supplement. All right, for pi-thirds, same thing. We're going to take pi-halves and subtract pi-thirds to get our complement. Remember that these are understood ones on top in front of the pi, so we're really doing 1/2 minus 1/3, which is 1/6. So pi-6. And for the supplement, we're going to do pi minus pi-thirds. So that's really 1 minus 1/3. We get 2/3. So 2 pi-thirds is the supplement. For pi-fourths, complement, we're going to do pi-halves minus pi-fourths. So you're going to type that as 1/2 minus 1/4. And we get 1/4. So pi-fourths is our complement. So sometimes you do get the same angle you started with. When you're trying to sum to 90, obviously 45 and 45 give you 90, so these are 45-degree angles here. All right, for the supplement, pi minus pi-fourths. So you're going to type 1 minus 1/4. As a fraction, that's 3/4, so we have 3 pi-fourths. Okay, 2 pi-thirds. To get the complement, we're going to do pi-halves minus 2 pi-thirds. So you're going to type that as 1/2 minus 2/3. All right, notice we get a negative answer. If we change that to a fraction, that's negative 1/6. Negative pi-6. We're not allowed to have negative answers, so we're going to say no complement for that problem. Okay, and then for the supplement. Supplement will be pi minus 2 pi-thirds. So you would type that as 1 minus 2/3. Change to a fraction, and you get 1/3. So pi-thirds is the supplement. Okay, you'll notice for these last two examples, they don't have pi's in them. As long as you still don't see a degree symbol on these, they're still assumed to be radians. So this is 1.5 radians, and this is 2 radians. We're still going to approach these problems the same way. So to find my complement, I'm going to take pi-halves and subtract 1.5. Okay, the way you type these in your calculator is going to be a little bit different. In all the other examples, we had a pi in both things that we were adding or subtracting. Okay, in this one, we have a pi in the pi-halves, but we do not see a pi in the 1.5, which means the pi is already included in the 1.5. So when we type this in our calculator, we have to include our pi as well. So this time you are actually going to type pi-halves minus 1.5, and it's going to be a decimal, and that's okay. And it'll be a decimal that won't change back to a fraction. So I'm just going to round to the nearest hundredth, which is 2 decimal places. So this will be 0.07 radians for the complement. And then for the supplement, you're going to do pi minus 1.5. Remember, your pi key is second, and then you hit the caret key under the clear key. Pi minus 1.5. Rounding to the nearest hundredth again is 1.64 radians. So when the number you're subtracting or the angle you're subtracting is a decimal, that means the pi has already been included, so you're going to include your pi as well when you type it in. Okay, and the last one is 2 radians. So for the complement, I'm going to do pi-halves minus 2, and I'm going to type in the pi. So pi-halves minus 2 gives me something negative again, negative 0.43, which we cannot have. So there's no complement for that angle. It's already bigger than pi-halves. And then for the supplement, we'll do pi minus 2. Pi minus 2 is 1.14 radians. Okay, so now let's look at how we convert back and forth between radians and degrees. So we've already talked about how pi radians is the same as 180 degrees. So we're going to put this in ratio form, which means fraction form, and we're going to use that to convert. Okay, so when we want to go from degrees to radians, we're going to take our fraction and we're going to multiply it by pi over 180 degrees. Pi radians over 180 degrees. This fraction, because these two things are equal, this fraction is really the equivalent of 1. So we're basically multiplying our angle by 1, which means we're not changing it, we're just changing the form that we put it in. And if we want to go from radians to degrees, we're just going to flip that fraction and we're going to multiply by 180 degrees over pi radians. Okay, so let's start with this one, 135 degrees. So we want to go 2 radians. So we're going to multiply that by pi over 180. Now what you should notice happening with these degrees is this degree symbol on top will cancel this degree symbol on bottom if you have it set up correctly. All right, to type that in the calculator, remember I'm not going to type the pi, I'm just going to worry about these two numbers. One's in the numerator and one's in the denominator. So I can type this as a division problem. 135 divided by 180 is a decimal, and then get that in fraction form, it's 3/4. So this is the same as 3 pi/4 radians. All right, these rules can be used for negative angles as well. So same thing, I'm going to multiply this fraction by pi over 180 degrees. My degree symbols cancel. I've got negative 270 on top. I'm dividing by 180 on the bottom. And I get that as a fraction, and it's negative 3/2. So my radian measure is negative 3 pi/2 radians. Okay, my next example is already in radian form. So this time I'm going to multiply by 180 over pi to change it to degrees. So 180 degrees over pi. What you'll notice with these is lots of times you'll have a pi on top and a pi on the bottom. And when that happens, they cancel. Okay, so what you're left with is you have a negative out front, you have a 180 in the numerator, and a 2 in the denominator. So negative 180 divided by 2. Or you could type it as negative 1/2 times 180, because there's an understood 1 here. Whichever way you prefer is fine. And you get negative 90 degrees. Okay, now here we have just a 2. There's no degree symbol on that 2, so that means that's in radian form. So I'm going to multiply by 180 over pi to put it in degree form. Okay, this one's a little different than the last problem. In the last problem, my pi's canceled. In this one, they don't. I don't have a pi to cancel this one with, which means it's going to stay down there. I have a 2 and a 180 on top. So 2 times 180 is 360. So there's two ways I can write my answer. I can write it as 360 divided by pi degrees, or I can go ahead and get that as a decimal. 360 divided by pi is about 114.6 degrees. And which answer or which form you put it in will mainly depend on what your instructions say for the problems that you're working out. Okay, now I want to convert 120 degrees to radians. So I'm going to multiply by pi over 180. Cancel my degree symbols out. So it's a 120 on top and a 180 on the bottom. And I realize some of this math you can do in your head with mental math, but I'm going to use the calculator so you can see exactly how I'm getting my answers. That's the same as 2/3, so 2 pi/3 radians. Okay, pi/3, we want to go back to degrees. So we're going to multiply by 180 over pi. This time our pi's cancel. We have a 180 in the numerator and a 3 in the denominator. So 180 divided by 3 is 60 degrees. And negative 3 pi fourths, multiply by 180 over pi. Our pi's cancel. Okay, this time I can type this in two different ways. I can type negative 3 times 180 and then divide by 4, or I can type negative 3 fourths times 180, and both of those will give you the same answer. Negative 3 fourths times 180 is negative 135 degrees. And the last one, negative 50 degrees. This time I'm going back to radians. So I'm going to multiply by pi over 180. Cancel the degree symbols out. I've got a 50 on top, a negative 50 on top, and a 180 on the bottom. Change that to a fraction, and I get negative 5/18. So negative 5 pi 18ths radians. So we'll be doing a lot of converting back and forth between radians and degrees. Okay, now a couple applications using radians and degrees and angles. We want to find the arc length around a circle. We talked about this just a few minutes ago, but remember, arc length is just the distance around a portion of the circle. So if you have an angle opening up to a portion of the circle, that length right there, if it was stretched out straight, that's your arc length, and we use an S to represent that. The angle opening up to that arc, we call theta, and then your radius obviously is the distance from the center of your circle to the edge, that's your R. So if you have any two of those three things, you can find the one that's missing using this formula. Theta equals S over R. Now there's one catch to this formula. Theta must be in radians for this formula to work. So if you're doing this problem in degrees, you want to convert first. Convert your degrees to radians and then work it out. Okay, so for the first example, I have a radius of 4 and I have an angle of 240 degrees. I want to find the arc length. Okay, first thing I'm going to do is I'm going to take this 240 degrees and I'm going to convert it to radian form using what we just did up here. I'm going to multiply by pi over 180. So 240 on top, 180 on the bottom. Change it to a fraction, you get 4/3. So this is really 4 pi thirds radians. Okay, so now I'm going to plug in what I know in my formula. I know that theta is 4 pi thirds. S, I don't know. And I know that R is 4. So there's my formula. Basically, I have a fraction equals a fraction. That's called a proportion. To solve that, we usually cross multiply. So I'm going to cross multiply these. 4 pi times 4 is going to be 16 pi. And then 3 times S is going to be 3S. And we want to get S by itself, so we're going to divide both sides by 3. Now there's two different ways to leave your answers on these problems. Sometimes you'll be told to round to a decimal value, and other times you'll be told to leave your answer in terms of pi. If I want to leave my answer in terms of pi, this is it right here. I just need to make sure that that fraction won't reduce, and it won't. So that would be my answer in terms of pi. That just means don't type pi in your calculator, but leave pi with your answer. If I wanted a decimal answer, I'm going to go ahead and type it in, 16 pi divided by 3. So my arc length is approximately, I'm just going to round to the nearest tenth for now, 16.8 feet. Your arc length is always measured in the same units that your radius was measured in. Okay, for the second example, we're missing theta. We know our S and our R. So we have theta equals 6 over 5. That's pretty much our answer. If you wanted it as a decimal, you can go ahead and do 6 divided by 5, which is 1.2. So we can say this is 6/5 radians or 1.2 radians. And for the last one, I have 100 degrees and I have an arc length of 35. I want the radius. So I'm going to convert my degrees to radians first. Cancel those degree symbols. I've got 100 divided by 180. Change that to a fraction, and it's 5/9. So this is really 5 pi nonths radians. Okay, so if I plug in my formula, I have 5 pi nonths for theta. I have 35 for S, and I don't know R. So let's cross multiply again. It's going to give me 5 pi R. And here I have 9 times 35, which is 315. And I want R by itself, so I'm going to divide both sides by 5 pi so that I cancel these out. Be careful how you type this in. If you look at my calculator, I'm going to type it 2 different ways. I'm going to type 315 divided by 5 pi. Notice that gives me 197.9. And then I'm going to do 315 divided by parentheses 5 pi. That gives me 20.1. When you're dividing by a quantity, if that quantity is made up of more than one thing, it has to have parentheses. So the correct answer here is actually the 20.1 centimeters. Okay, another application using angles would be finding the area of a sector of a circle. Think of a sector as just being a pie slice. You'll be given an angle and a radius, and what you want is the area that that angle and radius cover. So, for example, the shaded area there. All right, the formula for this is, let me put area of sector. I'm going to use SEC to represent sector. It's theta over, and this is going to be either 360 or 2 pi, depending on if you're dealing with degrees or radians. So 360 times the area of an entire circle, which is pi r squared. Just remember that this 360 could also be 2 pi. You're just going to use whichever one's more appropriate for your problem. Okay, so for the first one, the area of the sector, because I have degrees, I'm going to use 360. So I'm going to put 200 degrees over 360 degrees times pi times my radius squared. All right, let's practice getting our answer in terms of pi first, which means you're going to type in everything but the pi. So 200 divided by 360 times 20 squared. And it is a decimal, so we'll change that to a fraction, because if you're leaving your answer in terms of pi, you normally want it to be an exact answer. So that gives me 2,000 over 9. Now you can put your pi back with it. That always goes in the numerator. Because we're finding area, our units have to be squared. So 2,000 pi over 9 meters squared. Now, if we wanted that as a decimal, we'd go ahead and put the pi in, 2,000 pi over 9, and it's approximately 698.1 meters squared, and I'm running out of room. So just pay attention to your instructions as far as how you want to leave your answer. Okay, for the next problem, the area of the sector. This time I'm given radians. Okay, so I'm going to use 2 pi on the bottom. So we have 2 pi thirds over 2 pi times pi 10 for our radius squared. All right, notice in this problem you have 3 pi's. These 2 pi's are considered part of the numerator, and this pi is considered the denominator. That pi in the denominator can cancel one of these pi's out, but not both. So usually I cancel out the one above it. So what I have left that I'm going to type in my calculator is 2/3 divided by 2 times 10 squared. So 2/3 divided by 2 times 10 squared. Fraction again, or it's a decimal again, change it to a fraction. That's going to be 100 pi thirds centimeters squared. Or, if we want to go ahead and get the decimal value, 100 times pi divided by 3 is 104.7 centimeters squared. Okay, and then the last one, area of the sector, I have a radian measure for theta, so I'm going to use 2 pi on the denominator. So I'll have pi sixths over 2 pi times 5 squared. Okay, again, I can take this pi in the denominator and cancel one of these pi's out. I'm going to cancel this one. Be careful though, when I'm canceling that pi out, there's still an understood 1 next to it. Okay, so when I type this in, I'm not typing 6 divided by 2, I'm typing 1/6 divided by 2. So I have 1/6 divided by 2 times 5 squared. And change that to a fraction. So that gives me 25 pi twelfths feet squared, or let's get that as a decimal, 6.5 feet squared. Okay, one last thing that I want to cover while we're talking about radians and degrees is how to change your degree form. Okay, we can change our degrees to something called degrees, minutes, and seconds. And this is mostly used when we do application problems talking about bearings like angles and navigation problems. So we'll see this some later. And then we can also take degree, minutes, and seconds and change those back to decimal degrees. So let's talk about first how to take a decimal degree. A decimal degree is what you're used to seeing. This right here, 37.56 and 80.125, those are decimal degrees, just degrees that are decimals. Okay, to change those to degree, minute, second in the graphing calculator, you're going to hit the second button, and then you're going to hit the angle button, which is actually the apps button. So second apps gives you the angle menu. So this is really the angle menu, but you have to hit the apps button. And then you're going to choose number 4. So if I bring up that menu, notice how number 4 has an arrow and it says DMS. That's the one you're going to choose to take you to degrees, minutes, and seconds. So let's go ahead and we'll do these first two down here. All right, so I'm going to take 37.56 and I'm going to hit second, apps or angle, choose number 4 and hit enter. And that tells me that that angle is 37 degrees, 33 minutes, and 36 seconds. So your minute mark is an apostrophe and your second mark is kind of like quotation marks. Now, one other thing that's important whenever we're talking about degree, minute, second is how you round. If I'm told to round to the nearest degree, normally we think of rounding as if the number behind it is 5 or higher, we round up. Well, because we're talking about minutes and seconds, that's going to change a little bit. There's 60 seconds in a minute, so 30 or higher is going to round up because 30 is half of 60. So if we're told to round to the nearest degree, we're going to look at our minutes and see if we have 30 or more. If we have 30 or more minutes, then we could round up to the next degree and say that that's 38. If I'm told to round to the nearest minute, I'm going to look at my seconds. If my seconds are 30 or more, I can round up to the next minute. Okay, so if I was rounding this one to the nearest minute, I would say 37 degrees, 34 minutes, because 36 is greater than 30. If I was rounding to the nearest degree, I'm looking at my 33 minutes. That's greater than 30, so I could say 38 degrees. So your rounding changes just a little bit. This next one is 80.125. I'm going to hit second angle, DMS, number 4, and hit enter. So this one is 80 degrees, 7 minutes, and 30 seconds. If I'm not told to round at all, I'm going to write all of it. But if I am told to round, that's when you want to pay attention to those new rules. So for this one, if I was told to round to the nearest minute, I would round up to 8 minutes because 30 seconds, that is half. If I was told to round to the nearest degree, I would stick with 80 because 7 is not half. I would need to be at least 30 here to round that up to an 81. Okay, now going the other direction. If we want to take something that's already in degrees, minutes, and seconds and change it back to its decimal value, the way that we're going to do that is you're going to put in your degree first. So you're going to put that in, and then you're going to hit second, apps, or angle, and you're going to choose number 1. That gives you the degree symbol. Then you're going to put in your minutes, and then you're going to hit second, apps, or angle, number 2. That gives you the minute symbol. And then for your seconds, you're going to go ahead and type the seconds in, and then you're going to hit alpha, and then you're going to hit the plus sign, and that gives you your quotation marks for your seconds. So let's try one. All right, so here I have 336 degrees. So I'm going to hit second, apps, number 1. There's my degree symbol. I have 10 minutes, so 10. Then I'm going to hit second, apps, number 2 for my apostrophe, for my minutes. And I don't have any seconds. If we go ahead and hit enter, it gives us our answer since we don't have any seconds. So we have 336, and then you're going to round to whatever you're told to round to. I'm just going to do the nearest hundredth for right now. That would be 0.17 degrees. All right, it works for negative angles as well. Let's try the next one. We have negative 42, second, apps, put in my degree symbol. Then I have 8, second, apps, number 2 for my minutes, and 30, alpha plus. Alpha is the green key, and then the plus key, and that puts my quotations for my seconds, and then hit enter. This is negative 42.14 degrees. So that's how you'll convert back and forth between decimal degrees and degrees, minutes, and seconds if it's needed.